Good afternoon, everybody. We're on lesson 84 today, logarithmic differentiation. And before you get all upset and think, oh no, logarithms, this time it really is a time saver and a rule saver. If you look at this first problem, it's 84.1 and it says y equals x squared over 3x plus 2 to the fourth power, and we're supposed to find dy dx. Well, we would have to use the quotient rule and the power rule, which means the chain rule, and there's a lot of different ways to make mistakes when you have to use all those rules combined. So instead, what we're going to do is we're going to take the natural log of both sides, right? So ln of y equals ln of this whole thing. Okay, so now, since we're taking the natural log of this thing right here, the rules for logarithms, which means the rules for exponents, apply. So this is this divided by this. Okay, and since it's a natural logarithm, when you're dividing, you subtract the logarithms. So this becomes ln of y equals ln of x squared minus ln of this, 3x plus 2 to the fourth. All right, now, this is a power, so because it's a logarithm, that power gets multiplied times the logarithm. This is a power. Since it's a power and it's a logarithm, it gets multiplied times the logarithm. So simplifying even further, we get 2 ln of x minus 4 ln of 3x plus 2. All right, so now it's as simplified as we can get it. Now let's take the derivative of this. So the derivative of ln of y is 1 over y dy equals 2 times the derivative of ln of x would be 2 over x, and since it's with respect to x, it's dx. Then minus 4 times the derivative of this, so be careful. So that's going to be 4 over 3x plus 2, but now it has to be multiplied by the derivative of what's inside of here, because our formula is for the derivative of natural log of x, not natural log of 3x plus 2. So we have to multiply the chain rule by the derivative of what's in here. So what's the derivative of 3x plus 2? It's 3. And then that was with respect to x, so this is dx. Okay, so the whole object here was to get dy dx. So the next thing we'll do is divide by dx. Okay, well those just cancel out. And now we have this 1 over y. So we need to get rid of 1 over y to get dy dx by itself, which means we multiply both sides by y. Okay, so this will be dy dx equals y times this, 2 over x minus 12 over 3x plus 2. And then the last step is, you notice that there's no y's except for this one we just put here. Can't have y in the answer. But if you look back up here, this is what y is equal to. So instead of writing y, we'll put x squared over 3x plus 2 to the fourth, and now it's times 2 over x minus 12 over 3x plus 2. All right, so that's the answer. And it looks pretty complex, but it's still was easier than using the quotient rule, the power rule, and trying not to get lost with the chain rule and everything else. Okay, we've got 4 more of these, and they just get a little bit more complicated each time. So over on page 430, 84.2, let y equal x cubed times the square root of x squared plus 1 over x plus 2 to the 6. And we're supposed to find dy dx. So if you think that you could do that easily with the power rule, the quotient rule, the chain rule, go ahead and try it if you want. It's pretty complex. So instead what I'm going to do is I'm going to take the natural log of both sides. And while I'm doing this, I'm thinking of what I'm going to do next. Matter of fact, instead of writing that as square root of x squared plus 1, I'm going to write it as x squared plus 1 to the 1/2. Because that's the form I'm going to need it in to work with the rules of logarithms. Okay, so here we go. First things first. ln of y equals, this is divided by this, so it's going to be these subtract this one. So ln of x cubed times x squared plus 1 to the 1/2 minus ln of x plus 2 to the 6th. All right, these are multiplied. When they're multiplied, what do we do to the logarithms? Well, we subtract it to divide, so what do we do to multiply? We add. All right, so we're going to have natural log of y equals ln of x cubed plus ln of x squared plus 1 to the 1/2 minus, we don't have to do anything to this, so we can go ahead and bring the 6 out in front because it's a power. All right. Next, simplify again. This will be 3 ln of x plus 1/2 ln of x squared plus 1. And then minus the 6 ln of x plus 2. All right, does somebody remember what we did next? So we wrote everything in terms of the logarithms, and then we took the derivative of each piece. All right, so this becomes 1 over y dy. This will become 3 times 1 over x, or 3 over x dx. This will become 1/2 times the derivative of this, so that'll be, in the denominator, we'll have 2x squared plus 1, but don't forget now we have to multiply by the derivative of this. So the derivative of that is 2x, and that's dx. Then minus 6 times the derivative of this, which is that dx. Okay, then next, we divide everything by dx because we wanted dy dx. And to get dy dx by itself, we have to multiply both sides by y. So the whole thing is going to be multiplied by y. So this becomes dy dx equals y times 3 over x plus, oh, these 2's cancel. So we get x over x squared plus 1 minus 6 over x plus 2. And then, way up here, this is what y was. So instead of writing y, we're going to put this in. So dy dx will be equal to x cubed times the square root of x squared plus 1 over x plus 2 to the 6th, and then times this, 3 over x plus x over x squared plus 1 minus 6 over x plus 2. All right. Next. This is at the bottom of page 430. Don't worry, we only have 5 of these. And I think this one is the longest one that we've got. All right, you'll probably be able to tell when I start writing it that it's pretty complicated. So it's the square root of 3x plus 2 times x cubed plus 1 to the 4th times 5x minus 3 squared over x cubed minus 2 to the 5th power. And find dy dx. So why don't you guys start on it for a little bit. I'll give you a couple of minutes before I start it. See how far you can get. All right, you don't have to look at the video until you're ready. ln of y equals ln of this whole thing. So since these are multiplied, I'm going to go ahead and say ln of 3x plus 2 to the half plus, ln of x cubed plus 1 to the 4th plus ln of 5x minus 3 to the 2nd, and then minus ln of x cubed minus 2 to the 5th because it's divided. Okay, then that further simplifies to 1/2 ln of 3x plus 2 plus 4 ln of x cubed plus 1 plus 2 ln 5x minus 3, then minus 5 ln of x cubed minus 2. All right, now take the derivative of both sides. So this will be 1 over y dy, and this will be 1/2 times this, so that'll be 2 and the 3x plus 2, but don't forget we have to multiply by the derivative of what's inside here using the chain rule. So the derivative of this is 3 plus, this will be 4 over x cubed plus 1, but we also have to multiply by the derivative of that. So what's the derivative of x cubed plus 1? 3x squared, and then that's a dx, plus 2 over 5x minus 3, but we have to multiply by the derivative of that, which is 5, and then minus 5 over x cubed minus 2, but then multiply by the derivative of what's inside. So that's times 3x squared. Oh, and this is a dx, and this is a dx. So what do we do next? divide everything by dx. Okay, and then we've got to get rid of this 1 over y, so we multiply the entire problem by y over 1. So this will be dy dx equals y times trying to see how much we're going to simplify this. I guess go ahead and multiply this out. 6x plus 4 plus, nothing cancels here, 12x squared over x cubed plus 1 plus 10 over 5x minus 3 minus 15x squared over x cubed minus 2. Okay, so then the last thing is to take this y value and put it right here for y. So I'm going to try to write small enough that I can get that to fit. So dy dx will be equal to the square root of 3x plus 2 times x cubed plus 1 to the 4th times 5x minus 3 squared over x cubed minus 2 to the 5th, and then times this right here. So 3 over 6x plus 4 plus 12x squared over x cubed plus 1 plus 10 over 5x minus 3 minus 15x squared over x cubed minus 2. There we go. All right, so that's it for the material for this week. And tomorrow I'll just post the review problems for you, so you'll have those to work on tomorrow and over the weekend. All right, guys, have a good day.